Paul is an experienced acoustic, noise and vibration design consultant and has approximately 25 years experience working in this field. His experience also includes writing and reviewing detailed technical reports as part of window environment and architecture studies. Welcome on the stage.
Thank you very much. I'm here today to talk about acoustics, noise and vibration and the urban design. I've got a presentation which hopefully is ready to go. Hi guys, is the acoustic presentation ready? There we go. Okay, so just a little bit about myself before I start the presentation. So I've been in the region approximately 25 years, just a little over 25 years. I came to the UAE from the UK, as you can probably tell from my accent, to head up an acoustics division within a big multinational engineering consultancy. Very quickly, we became one of the premier engineering consultancies for acoustics in the region, and shortly afterwards I left to not only start my own consultancy, but I also recognized that there was a lack of testing and certification facilities within the UAE and within the GCC. And so it was important for the construction industry and the building industry in general to have that testing and certification, because while a lot of products and a lot of systems could be imported, there was a recognition that the GCC, the UAE, Saudi Arabia specifically had the technical capabilities to develop and produce products of the caliber to be used for international standard projects, but they just simply did not have the pieces of paper to certify them and to prove that their systems were capable of achieving the same results as the European systems. So with the establishment of my testing and certification laboratory, we've also very recently developed an audio demonstration facility. Part of our role is the ability to develop a 3D model of any given space so that we can predict and show to clients what their spaces are going to sound like, which before anybody commits a huge amount of money to what could be a very impressive architectural space, it's very good to be able to predict what these spaces are going to sound like. Just another couple of minutes before the presentation gets put up. So the principle of urban acoustic design. Quite a long time ago, the World Health Organization put a lot of time and research into developing standards by which a lot of people in the world perceive a certain threshold of noise before they can become annoyed by it, before noise becomes intrusive and annoying. That threshold was set at a specific level, around about 55 dB, and most of the international standards that exist today around the world try to achieve that value. Now, it's not the easiest thing to achieve in the world, especially when, for example, within the UAE and surrounding countries. Thank you. Perfect. A lot of the surrounding infrastructure, for example, roads, a developer or a contractor within the UAE or Dubai will not really have the ability to control the amount of noise that comes from a road. Maybe it is possible to put screening up around the outside of a development, but even so, that's very limited in the way that that can control the noise that affects a property. And one of the most prevalent, I would say, complaints that residents will have, that developers are very familiar with, that users are very familiar with, that generally the top 5 complaints of any development, almost 3 to 4 of those will be noise related. And when you have a development which has a good acoustic environment, essentially what that is a perception of quality to the end user and to the developer. If you have a very poor quality acoustic environment, that is something that is recognizable almost straight away. And I'm very well aware of almost everybody that works in our industry. They will almost always say, everybody says, if I do my job properly, nobody notices it. But if I don't do my job properly, people notice it straight away. Now, I can speak to experience on that. If you can just imagine walking into a cinema and you can see the screen perfectly well, you can hear the sound from the speakers perfectly well, and there is nothing that interrupts your enjoyment of that film during the presentation, you're probably sitting there thinking, okay, it's a cinema. That's exactly what I expect. I expect to be able to see the screen. I don't expect to be disturbed. I don't expect to hear the air conditioning, and I don't expect noise to be coming from the adjacent auditoria. So essentially, you go through watching the film, you leave the film, and you think, fine, that was great. That's what I expected. However, if you can hear noise coming from the adjacent auditoria, or you can hear the acoustic, you can hear the air conditioning system, or other noise, the first thing you think is, my goodness, what is, this is not a cinema that's fit for purpose. Similar in a meeting room. If you can hear noise that comes from an adjacent space that interrupts your meeting, the first thing you think is what poor acoustics there are in the room. If you go through the meeting and you're not disturbed, you think nothing of it. The space was simply fit for purpose. So I would like to put myself at the top of the list of people that say that when they do their job, they're never noticed. So I go through my entire professional career hoping that nobody notices me, and then I know that I've done my job properly. Okay, my presentation then, I'm just going to talk briefly about the urban acoustic regulations that exist here in the GCC, what's good about them, and what could potentially be improved about them, or where the system currently falls down, and hopefully where things are moving in the future. So essentially, I'd like to talk to you about the risk and reward of good acoustic design. And essentially, that it all goes back to what I've just talked about the perception of quality to the end user. A space where, for example, a meeting room where you can hear every word that's being said is obviously fantastically rewarding. We did a project for a number of legal entities, and they brought us in to have a look at some of their meeting spaces. And the complaint was the acoustics in the rooms that they have, and it was a generic copy and paste cookie cutter design that they'd used in all of their offices all around the world. And they found that for various reasons, when they were having conference calls, they could not hear all of the words that were being said, not only from their system, from the people who are on the other side of the meeting space, but they had consistent complaints from the people who they were meeting with that they could not hear what my client was saying in the meetings. Now, this is a client who did legal work for government entities, for seriously big projects that ran into the value of tens, hundreds of millions, sometimes even billions of dollars. And their complaint was that they have a really big problem if there's a presentation and somebody misunderstands the word 1,000,000 for 1,000,000,000. There is a big problem there, and they cannot afford to have those kind of misunderstandings. So our brief was to come in and help them redesign the space so that every single word could be perfectly understood. And so we assisted them with that. So obviously the reward from them is that they don't have a problem with millions and billions. And the risk, having not undertaken that work, is that there was potentially a serious issue with miscommunication. So when we talk about acoustics in the built environment, both internally and externally, we respond to acoustics in four main ways. It affects our behavior. It affects our actions. When you are subject to excessive amounts of noise, it certainly changes our behavior. I don't know if any of you have noticed or anybody knows. You're driving in your car. You have very upbeat, very passionate music on the radio. studies show that that significantly increases the speed at which people tend to drive. Whereas if the radio is off or there's a very calm piece of music, it actually tends to result in people driving at a much slower rate. Now, that's just simply within the world of driving and how that affects behavior, but that behavior is replicated and it affects our behavior in all aspects of our life. If you're subjected to excessive amounts of noise in the workplace, it makes you significantly less productive. If you're subjected to significant amount of noise when you're trying to rest and sleep, your rest and sleep is interrupted. That can seriously affect your health. And a lot of studies have shown that over the long term, sleep deprivation is one of the biggest killers and one of the biggest detrimental effects on health in the world. Not directly from the exposure to noise, because if you're exposed to excessive amounts of noise, yes, that will affect your hearing, but over a prolonged period of time, that will be a significant indicator increase of heart disease, which does have a significant shortening effect on people's lives. Physiologically, it affects you physically, so much more in the line of the health that I've just told you about there, and the fact that a short, sharp noise, when you wake up in the morning, you set a very loud alarm, that fight or flight instinct that kicks in when the alarm suddenly goes off, that's a shot of cortisol that you get into your system, and it takes several hours for that to leave your body. Cognitive, again, the ability to think. I don't know if many of you at college or university, whether you found that you studied and you did your work when you had some music on in the background, or a nice quiet space. I'm sure if you were subjected to a significant amount of noise, everybody has found that's a very difficult environment to work in. And psychological, it affects your moods. We've all been subjected to how our moods can change with nice music, with heavy metal music, with various kinds of things, and I'm sure we've all been in a situation we've told someone else that the music they're listening to sounds like noise, whereas the music we listen to is obviously not noise, and vice versa. So the regulations that exist in Dubai previously were known as the Green Building Regulations. They are now the Dubai Building Code, and they are mandatory. So the acoustic regulations that are required to be complied with by a building design, both outside of the building and inside of the building, are mandatory regulations, and they must be complied with by law. Now, this might be a bit of news to a few people, because while the regulators and the authorities are very good at citing the regulations, which are based on British standards, they are not so brilliant at enforcement, but we will come back to that a little bit later. Abu Dhabi has the Estidama regulations, which I'm sure a lot of you are familiar with, the sustainability guidelines for Estidama. And also, and this is obviously a precursor to Dubai and Abu Dhabi, developers very often have their own criteria. So if we look at Jumeirah hotels, if we look at Imar, Damac to a certain extent, Nikhil, but Hilton hotels, Sheraton hotels, they all have their own brand standards that they expect their developments to comply with, irrespective of the regulations. These are above and beyond the regulations, or simply supplementary to them, because in a lot of cases, the developer's own standards are very similar to those of the regulators. So these are actually the regulations that in Dubai. They don't go into a huge amount of detail. All they simply say is that for residential and various type of residential buildings, it must comply with the UK building code. For healthcare, for educational, for commercial, industrial facilities, they have their own respective standard that they must comply with. For Estidama, for Abu Dhabi, again, they simply cite various standards which are in line with the UK regulations. And again, they must be complied with. How demonstration to that is undertaken is the regulators and the local authorities do not have their own experts in the municipality that look at this. They expect each development, each architect, to have their own acoustic expert that will do a review and are expected to produce a report at the end of the design stage to say the acoustic design of the development complies and produce a list of each of the individual spaces within the development and to show this area complies, and here is the mathematics, here's the evidence behind it. And a simple checklist is provided that says, does the room, does the area comply? Yes or no. If it doesn't, what needs to be done to supplement that? And various elements are looked at, how the noise travels through and around the building. And this is fairly essential because when we look at the testing and certification of individual products and materials, this testing and certification is done in a laboratory. It's under perfect conditions. As soon as that product comes to the site, it is then exposed to a lot of imperfect conditions. The structural slab may not be absolutely perfectly within tolerance. The facade may not be perfectly correct. The building services may be creating penetrations through various parts of the building. And as a result, you've got what we call flanking noise. That means a noise path that is other than directly available for the sound to travel from one space to another. And those flanking noise paths all add up together to create what we need to allow for a tolerance between the laboratory perfectly tested environment and the site test. Now, a competent and experienced acoustic consultant will know what that tolerance is. They will know how much of a tolerance that needs to be adjusted based on the design of the building they've currently seen, and they know what kind of acoustic materials need to go into the use of that building and the space in order to make sure the internal acoustics comply. Externally, when we're talking about the external environment, it's really about working with the mechanical services engineers and the guys that are effectively in charge of the control of the traffic that come in and out of that development, because those are really the only two sources of noise that are going to, that building is going to have an effect on the external noise environment. And again, a competent acoustic consultant will be able to look at that and assist the mechanical services engineer to make sure that the intake and the discharge of building services does not create a problem for adjacent spaces and adjacent buildings. And they can also look at traffic flow and ensure that the traffic that development is going to add to the environment doesn't have an adverse effect on the surrounding environment also. There's various tools that acoustic consultants use in order to measure and assess the impact of the internal and external environment. This is a graph that shows the European rating system for building services. We are very well aware that across the GCC, although the UAE, Dubai and Abu Dhabi specifically cite British standards, there are many countries across the GCC that don't cite British standards, they cite American standards. And so the ability to understand how those two are similar and how they differ is a very important aspect of consultancy within the wider region and not just within the UAE and Dubai. Helps if I press the right button. Sound transmission, I've touched on it very briefly. This is something that is very important to understand. There is a big misconception, or there's a big misunderstanding, as I say, within the industry. A lot of people confuse the principle of stopping noise traveling from one space to another, and that is confused with the requirement to control the noise as it reflects within a room. One is sound insulation, and if you think about it, it's very similar to thermal insulation. You are stopping the sound, you are stopping the heat transferring from one space to another. The other is control of what we call reverberation or echo within the same room. Now, where the confusion comes is a lot of people think, well, if you stop the sound from reflecting and bouncing around within a room, you also stop it from escaping and going to the room next door, and that is not the case. So it's very important that the expert involved in the project understands the difference between those two principles. And that really covers most of what I wanted to talk about within the discussion and the introduction to the regulations and the criteria. I thought for the last section of the talk, if there's any questions or if you wanted to have a discussion about the noise, the acoustic urban environment? Or
I don't know.
I'm
Maybe
quite happy to
somebody
take
asks.
questions.
Do you have any question for Paul?
No.
Do you have a question for Paul? I'm sure you have. You have a fix exactly to do it.
Okay. No, I'm
Everybody
very
too shy.
yes, that's not a problem. Okay. Well, good. I mean, I hope, yes. I hope I laid everything out very clearly. And yeah, look, I mean, maybe the last thing I can just talk about, well, what happens when it goes wrong? It's very difficult to quantify and put a financial number on anything when it goes wrong. Typically, like most specialists within the industry, we're normally brought on board after something has gone wrong and somebody expects us to bring a magic bullet to fix everything. But look, what can go wrong is when you have insufficient control of noise and it is able to escape to any parts of the building. I've lost count of the number of times we've been brought on board, for example, in a project where you might have very large generators or very large building services, and they are not vibrationally isolated from the building. And we've been involved in a number of projects where, for example, a diesel generator or a very large packaged chiller unit is mounted directly to the structure in one part of the building, and we've had complaints from residents who are many hundreds of meters away on the other side of the building on a completely different floor. And it just so happens that the vibration traveling through the building, it gets amplified with distance. And it turns out that this particular resident was the absolute perfect distance from this equipment, where the amplification of the vibration was such that it was audible to him, but it wasn't audible to anybody else within the building. Now, the building maintenance people had been investigating this for 6 months and couldn't understand. You know, they looked at the plumbing, they looked at the fan coil units within the building itself, they looked at everything. They couldn't understand where this vibration was coming from. But they did notice that the vibration came into effect when effectively there was low power and the diesel generator kicked in, but they never put 2 and 2 together. And so when we came and did with the investigation and we identified that it was the generator, they said, no, this is not possible. This generator is 10 floors away and on the other side of the building. And we did a series of demonstrations where we started and stopped the generator, and then we showed that the vibrations exactly coincided when they started and stopped the generator. And it was simply a case of they hadn't isolated the generator from the building properly. So there you go. But that was just one tenant out of entire building that was being disturbed, but that could have potentially had the possibility of affecting many, many residents. So excessive vibration, inefficient MEP design, the user experience, and therefore the perception of quality, and therefore the damage to the reputation of the developer and the contractor can be significantly affected. If people constantly go through, and I'm not going to name any particular developers who are prevalent, let's just say in Dubai, but there was one in particular that went through a series of having got a reputation for building apartment blocks where you could pretty much have a conversation with your next door neighbor through the wall. And the air conditioning services were very noisy, and that generally when you were on your balcony, all you could hear was noise from the building services. And it took them only a couple of years to get that reputation, and it took them nearly 12 years to reverse that reputation. And that was just simply down to the fact that they never really took noise and acoustics seriously in the design and the development part of the building. I've got endless examples of where tenancy rents are significantly reduced because tenants simply don't want to pay when they're forced to live in those kind of conditions. Commercial premises where retail tenants, cinema tenants, for example, refuse to pay all of their rent. And why should they? Because they're being given a space that they can't use. A very well-known cinema brand here in the UAE, who was bought out and subsumed as part of a large retail developer a number of years ago. One of their flagship developments was a 12-screen cinema. The contractor got hold of the design and value engineered it, our favorite word, and decided that they could help reduce the time and expense of the development of that project if they reduced the type of material that they were using between cinemas. It turned out that they couldn't use 4 of the 12 cinemas, and so they refused to pay 100% of the tenancy of the rent. They negotiated 50% of the rent, and the retail tenant, if you can imagine how many thousands of square meters that was, the retail tenant lost a huge amount of money, and from that moment on vowed that they would never have a cinema development that wasn't designed and built properly, because they cannot simply afford to lose 50% of their tenancy contract. Again, that's purely down to poor acoustic and noise design. So it is the landlord's and contractor's responsibility for providing an environment that is fit for purpose. Now, I'm guessing after that, there's probably even fewer questions that anybody wants to ask. But that pretty much brings my talk to a close. Thank you very much for your time.
Thank you, perfect contribution.